My name is Benjamin Webb. I'm a software developer at the Internet of Water project, working on creating interoperability for water data in the United States. GeoConnects.us was inspired out of the selfie OGC experiment. So there is a geoconnects.ca and geoconnects.us, and hopefully many more geoconnects. The idea of GeoConnects is to use standards and best practices to create interoperable data. So without that, I'll...
Thanks, Ben. This is mostly Ben's presentation, but I'm just going to give a bit of a foreword here on some overarching principles. So in trying to set the stage, the project itself takes on a lot of the core principles that have been put forth by international standards in the last 5 or 6 years. Specifically the Worldwide Web Consortium with the spatial data on the web best practices, which inherits from the W3C data on the web best practice, as well as using OpenAPI as service description for API service description languages, and OGC API for that matter. So in recent years, as most of you know, OGC has really put forth an effort to try to make their APIs and web services a much more low barrier by simplifying the APIs and simplifying the encodings. So with all that said, we are going to talk a little bit about the OSGeo and OGC relationship later on today at 4:30 outside, which is related to this project, as well as some other presentations throughout the week. So I'm just going to leave that with you right now, and Ben will carry on with the rest of the presentation.
Thank you. So what is GeoConnects? At the end of the day, really all it is trying to promote fair principles in how we're publishing our data. So it is a project both providing guidance for data providers on how they can publish their water data to make it as easily discoverable, accessible, reusable, and interoperable. Simultaneously, it is a knowledge graph harvesting all of the data that organizations are publishing and linking them together into a related system, as well as also a community of practice of public agencies, academic institutions, community scientists, the private sector, who are all publishing, collecting water data in the US. So why does this really matter? When you Google currently, what does water data look like in Carrboro, North Carolina, or honestly any city in the world at this point, you see a myriad of websites, very little structured data, and you're not really sure what to take from it. And we know that this is not how web best practices work, because when you Google movies in Carrboro, North Carolina, which I would argue are less important than whether or not your water is safe, you get all of the movies playing. You don't need to be an expert to know, what movies are available, what movies you should go to. And the same thing is true for weather data, which is provided from weather.com, a private organization. So the goal is to eventually imagine a world where the same thing can be true for water data. So you don't have to be an expert to know the stream flow, the precipitation, the water quality, all of these things that organizations are continuously monitoring and publishing data about that is not reaching non-expert users. And so that is where the structured and interlinked data comes in. So what does this look like from a big picture? So I work for the Internet of Water Coalition, which is both providing data to GeoConnects, as well as a significant portion of our effort is collaborating with state and federal institutions on how they should publish their data. And then another part of my role is contributing to software to allow them to more easily publish their data. The goal of this really is to have the data user not even know that GeoConnects exists, but for it to just provide and feed information that non-expert users can use to better inform their decisions. So what does this look like right now? So the Internet of Water Coalition is partnered with USGS in the States to author guidance on web best practices for publishing water data. And currently we are working with US EPA, many state water boards, so California, New Mexico, Texas, Oregon, as well as interregional organizations like the Western States Water Council, CWASI, which is all of the academic hydrologic research, and then USGS. So the C4 diagram means that GeoConnects has a bunch of different pieces to it. We're going to start with the publishing and harvesting of data, which is the left side of the screen right here. So how does this what does this actually look like in implementation? So the first part of it is persistently identified real-world objects. And this is something that the Internet of Water Coalition is providing. So through PyGeo API, we are publishing reference features about watersheds, main stems, dams, bridges, HUC levels, states, counties, the type of stuff where people who are collecting their data can say, I'm collecting data and it's about this region, so that downstream there can be an aggregation of all data collected about these common features. But beyond just having these data published online in a free API, in an open API, they also need to be published with structured data. Structured data allows for unambiguous identification. So in a world where someone using the lowercase n name and uppercase n name are able to communicate that those are the same things. So that is what linked data provide and what GeoConnects relies on. It relies on people publishing their linked data on whatever website they choose to harvest or publish their data on. And that allows you to then expand and view your data in any JSON LD playground or any RDF triple store. In addition to that, though, not just having reference features, it's important to have organizations that are publishing their data online. So, for instance, USGS has landing pages for every single monitoring location in their network. And it also has a permanent identifier under the GeoConnects URL. And then, in addition, they are also publishing linked data in the head of their HTML pages that can be crawled by any search engine to be included in a larger aggregate data set. And what's great about this is USGS has the resources to build their own websites to, publish linked data. But one thing that I've worked a lot with Tom on in the last couple of years is setting it up so that PyGeo API, which there will be a presentation on tomorrow at 11:30. Out of the box is completely compatible to publish data within the GeoConnects ecosystem. So you don't need to have any developer knowledge in order to be able to publish your data and participate in GeoConnects, which is something we've noticed to be a really big barrier. It's not even necessarily publishing data online, or in a structured way, it's publishing data online, period. So that's why it's really great to have a super well adopted project like PyGeo API. And so what this also allows people to do is for the academics in the world that are publishing their data, are able to publish their data on Kawazi, which is similar objects or data store to Sciencebase, but this is for specifically academic institutions in the US. So any PhD student doing research on any part of their data is able to upload their data to HydroShare, which is something that Kawazi has supported for a while. But now they're also able to index it into the GeoConnects reference features. And anecdotally, I was actually at the Kawazi conference 2 weeks ago, and I was talking to someone who said that he knew of a professor who was monitoring data on a specific stream. And so he emailed her asking for the data, but she was busy, and so she didn't respond. And so the goal of GeoConnects is to make it so that he doesn't have to know that this person exists and doesn't have to email her, and that the data that she's collecting is also already on the stream. So the goal of that would be that you can just say, what data are people collecting on this stream? And what Kawazi is doing with this is allowing for any of the hydrologic data that is being developed by their grad students in the large set of universities to be able to do that. So anyone can, down the road, say, what data have people already collected about this? What research have people already done about this? And then the other side of it is having persistently identified objects. So this is a persistent identifier, which is really just a URL shortener. It's using the open source project URLs. But what it allows you to do is have persistent identifiers for every single object, because another big issue is link degradation, or you change the structure of your website, and all of a sudden, all of these descriptions that you've had about your website no longer point to it. So in addition, the GeoConnect system provides a permanent identifier service for anyone to register their data and index it into GeoConnects. So what we just covered was the permanent identifier service, the reference features, and the ecosystem of how people would publish and collect their data to GeoConnects. GeoConnects is the namespace that then gets harvested by the aggregator. So the aggregator is a collaboration with someone named Doug Fills, who is working on EarthCube, but it is really just a search engine crawler, because at the moment, we're still working on figuring out how that will work with Google search engine crawler. So what we have is actually our own crawler that goes in and collects all of that data as if it was a search engine, stores it in S3 compliant object store, and then also publishes the data that it has just crawled to a graph, knowledge graph, and then also to a free text search. And that is what allows a user to say, show me any data about the Boulder, where I'm from, Boulder, Colorado, or anything in the GeoConnects ecosystem. So this is a C4, not quite, diagram of how the indexing works. So GeoConnects provides a sitemap of all objects inside of the GeoConnects ecosystem. Through that, Gleaner is the equivalent search engine crawler that goes through the sitemap, crawls for the linked data of every single website, and harvest it into a object store, the text index, and then also an RDF graph. That is all what feeds upstream users using GeoConnects as a relevant user, or as an API developer who wants to be able to pull their data. So what this looks like on a website front end is you're able to explore the graph visually. You can start to click around, see. So this is looking at one hydrologic feature collected by USGS. And through the graph, you're able to say what other sites are USGS collecting data about, or what other hydrolocations exist in the graph, or what other hydrometric features. And these are all terms that were developed during the OGC selfie experiment in 2018. So currently, what this looks like is a lot of data all in one map. You can get, there is more data than even is shown on this map, but the point is that all of this data is related, even if it is being collected by disparate sources. So the USGS stream gauges interact with the water data exchange. All of the red triangles you see are actually water access points in the West, which is a really big issue in the United States over who has access to the water and who has the rights to it. But the goal is to create an ecosystem where all of this data exists in the same place and make it as interoperable as possible. And it's important that these identifiers have permanent identifiers that can resolve to JSON LD. So an example in this is that there are actually two Colorado rivers in the United States. There's the Colorado River we primarily think of, which is the one that flows through the Grand Canyon from Colorado all the way down out into the Gulf of Mexico. But there is also a Colorado River that flows through Texas. By having permanent identifiers, we are able to separately query for, show me the data that flows into the Colorado River in Texas versus the Colorado River that flows on the other side of the Continental Divide. Beyond that, there are a bunch of things you can read. The Internet of Water principles are the Webb best practices for how data should and can be published online. The Internet of Water tracker is how we have evolved and added permanent identifiers and features to our website, as well as we're developing documentation. There's a Python package to interact with GeoConnects, and then you can also read about the results from the selfie experiment, which is the origination of geoconnects.us and geoconnects.ca. So with that, thank you so much, and please reach out if you have any, well, does anyone have any questions, I guess?